thank you for joining us. This is the webinar for the VISI 2024.3 release. This will be reviewing the new features with the CAD side of the software, and we're going to get started. So first of all, let's talk about our support team. So we offer on-site and web training. Our help desk line is via 248-255-4348, and you can reach us by email, tst.support.mi@hexagon.com. You can also join us on the Hexagon customer portal. This is a way that you can submit cases, track your cases, upload your licenses, and so on. We also offer tech days, such as what we're doing right now with our webinars, seminars, etc. And we have an unmatched level of support. As you know, you can reach out to us, and you'll get an answer relatively quickly. So let's talk about the Hexagon customer portal real quick. So this is where you can access all your software licenses. This allows the company to be able to manage and access those licenses. You can submit technical support cases, track open cases via the technical support cases tab. And all the software, whenever there's a patch update, full releases, etc., will be available in the software tab. So speaking of licenses, it is very easy to install a license. All you need to do is have a computer connected to the internet and be able to log into the Hexagon customer portal, or even just upload them right from the license manager itself. So basically you go to the VISI launcher, or if you can get into VISI, go to the question mark drop down and select license manager. Note, inside the Hexagon customer portal there is a friendly name. This friendly name is fully customizable by you. So that means you can upload this, and instead of having an external Excel report, you can have everything all in the customer portal for the naming sequences that you would prefer. So here's just a quick video just showing that. So if we go to question mark license manager, you just go to install license, request license. Basically all you need is a server code to match up with your license here, and then it will download and automatically update your licenses successfully. So if you have maintenance renewal, if you have license extensions, you can update that right through here. So another little tool that we have under the question mark drop down is the remote support options. This is a way that you can reach out to us. So if we need to remote onto your computer, we'll walk you through these steps to get to the remote support, which would be TeamViewer. If you can't get to VISI, you can always get to the remote support button through the VISI launcher. So basically all you need to provide us is the ID and password that TeamViewer will automatically populate. Now we'll talk about our technical support services. We offer in-person or web services. These services could be used for installation and training of the new software. We could transfer your tool libraries, transfer your tool settings, and transfer any custom settings that you have. So feel free to reach out to us as mentioned with our contact information earlier. So I'll talk about the agenda. What do we plan on covering here? We're going to do the install and prerequisites, translators, user interface improvements, drafting and modeling, surfacing, analysis, Plotview and Dimensioning, standard elements and feature manager, mold and flow, progress, reverse engineering. Now we're going to talk about installation and computer prerequisites. So within the installation prerequisites, as with previous versions, you have to have Windows 10 or Windows 11 to be able to use the software. These have to be the Pro versions for each of these operating systems, and they're 64-bit. So note with previous versions, as well with previous versions that we've talked about before, files that are saved in 2023 can be brought back to VISI 2024.3. However, if you save a file out in 2024.3, it is not backwards compatible because of parallel versions. Now we're going to talk about what's new with the translators. Just real quickly, for import translators, everything highlighted in green is what is new. Same thing for export translators. You can see everything that is new here. We're going to talk about some of the new formats. Wavefront.obj extensions for export. It is now possible to export a .obj file out. Autodesk Filmbox. The .fbx files are now supported inside of VISI. It's possible to import and export these files. The reader supports meshes from FBX 6.1 and 7.7. So the writer supports FBX 7.4. And you now can import the stepfile.stpa extension. So within the export instances as a part document, the writer will be able to write out translators for the product of by assemblies. When a body has multiple instances in assembly tree, checking this option will now allow exports to save the body out only once and maintain the linking between the instances. As an example, previous exporting a CATIA V5 file out as a CAT product file for assemblies, each group would be represented in the assembly view tree, and now the bodies are inside that group. This feature allows flexibility during the export, providing an export file that is true to the representation that is in VISI, and it can save on file size, whereas multiple bodies are saved as one. Some additional improvements: it's now possible to handle assembly structures generated with layer nodes. This is helpful with CATIA V5 files, and it's now possible to import detail pages. So now we're going to talk about what's new with the user interface. So we have a new option for display selected number of objects. Basically, when you're using a command for block control, this shows you the amount of objects selected during the command. With block control, there's a new icon at the lower section of the screen that allows you to toggle block control on and off. And for dynamic highlight, you now have the ability to do a soft highlight. So if dynamic highlight is turned off, it'll just highlight the outline of whatever you're selecting. So here's just a quick video showcasing this. So if I use the attributes of visibilities, I can use block control, and for everything I'm selecting, you can see how this item selected area increases and decreases based on what is actually selected. So you can see the quantity of items. This includes elements, faces, edges, etc. And you can see everything that was selected in that possible area. We'll talk about the block control at the lower part of the screen. So whenever you have this active, this allows you to quickly toggle block control on and off, irregardless of if we're in a command or not. So if I have everything selected and I go to a command like change attributes, everything there will go right into change attributes. So I can toggle this option on and off. So now if I use delete, I can turn it on and off. I can select faces, I can select edges the same exact way. Okay, so as you can see, when I turn on block control, when I do my selections, automatically block control will be turned on within the command if I toggle at the bottom part of the screen. This eliminates me from having to go to system settings and check the box for block control, as everything is right in the interface. Now we're going to talk about the soft highlight with the dynamic highlight options. You can see the option works as before when we're highlighting with the option turned on. So if I turn off dynamic highlight now, you still get a highlight, but it's going to do a soft highlight so you can see the edges that are selected with the highlight. So when we're merging in data, it is now possible to merge in data and include your Plotview files. So you just have to check this box upon your export of a file. Within Save Part As, there is a new option that now allows you to define the saving modes in various options. So you can do this by single file, by layer, you can output a file format, and you have file naming options when you're doing by part. You now have the ability to create a external file by using Save As and Save Part As. This allows you to export directly as a GRP GRS extension. And within the Save Part As area, you have constraints to assign the part as saved within Save Part As. So let's talk about Save Part As real quick here. So if I do my selections, you can see how we can select within our dialog here, choosing the directory. This is as before. So now if we do a Save Part As, you have the ability to turn on this options area. Within this options area, you have the ability to do single file. Everything on one layer is its own separate file. Everything by part is its own separate file. You can save associated Plotview pages, etc. And you can choose which file formats you want by toggling these options. So you have an export directory for each one of these as well. And if I hit the checkbox, you can see how it will tell you how many files have been saved within Save Part As. You can see how if we do it by layers, each layer is going to be showing up as what it is. So again, save part as. If we do another selection here, you could do by parts. And when you do by parts, you can choose the entity name, you can customize the entity name, and this would show up in the part plus whatever's in the assembly manager. So for this one, 11 parts have been saved. And you can see how it shows up with whatever the assembly manager data name is. So once again, save part as. You can choose whatever your target work plane is, whether you want it to be absolute or a relative work plane that you've created. You can even select a work plane through this option here as well. So feature attributes and color retention. When you're doing application rendering through the Systems Rendering tab to show face colors, it is now possible to show finishing attributes and cylindrical faces and toggle those options on and off. Within the Assembly Manager CAD view mode, there's a new option called Gray Others. This option allows you to gray out everything except for whatever's selected. This is useful for being able to select objects and be able to see specifically the objects that you are visibly selecting. You also have the ability to do virtual transparency shading modes. So there's a new option that overall changes the shading mode for everything. There's a new slider bar to be able to do this. Within mixed rendering transparency, it is now possible to use the same slider bar. So if the value is 0, wireframe is represented. If it's more than that, obviously it becomes transparent. And we have show tangent edges in graphic selection. You have a new option for being able to mark smooth edges within your dialog. So let's talk about our feature color retention. So we have the enable disable face colors option, but under system settings we have the application rendering. So irregardless of this, if this option is turned on, your cylindrical attributes for feature manager based holes and your finishing attributes, which we'll talk about later, are enabled irregardless of the status of your face selection. So we'll talk about Gray Others now. If you select Gray Others, it grays everything out except for what you are actually selecting in the Assembly Manager list. You can see this makes it easier for being able to see specifically in a file where whatever you're selecting is. And we're going to talk about the slider bar transparency. This slider bar allows you by default to change the transparencies on the fly within this slider bar. You can see how it changes everything here. And for mixed rendering, you have that same type of slider bar. So when we do mixed rendering, whatever's selected right now, you can see that it is enabled. And then if we go to the slider bar options, or if we go into the mixed rendering, you can see here's your slider bar. If it's set to 0, everything is wireframe. If it's set to anything else, it is showing up as transparent. You can see how this also works when we just show only the transparency. So you can do different transparencies for what's mixed rendered and so on. So as you can see, face renderings do also work within the mixed rendering options. So transparencies work the same when you're selecting specifically faces within mixed rendering. Within Snapshot Manager, it is possible to enable the blank entities and dynamic sections. So when you're doing a dynamic section or using mixed rendering, the Snapshot Manager will apply this whenever you switch to that page. Any remarks that are added within this dialog as well can be exported out within your Excel and PowerPoint reports. There is an option for dynamic work plane by 3 points. This option is available in the preview, and now you can generate a work plane by 3 points. So as you can see, the work plane is dynamically updating. So let's talk about our mixed rendering options within Snapshot Manager. You can see how I enable only these 2 blocks. I'm also going to create a dynamic section off of this, which basically cuts everything in half. So within here, if I go into the Snapshot Manager, when I take a snapshot, it will retain the filters and as well as retain your dynamic section. I'll select another application point within here and take another screenshot. And you can see how it's going to actually retain that. So let's say if I turn my mix rendering off, if I turn my attributes of visibilities on and off, whatever page I switch to will display that specific rendering. So right now, if I close out of dynamic section, I close out of the attributes of visibility to show hide certain things, go back into snapshot manager, it will retain what those attributes of visibilities were in that current snapshot. You can see how it shows up with what layers there are, etc., etc. So you can see how the dynamic section, you can see how the attributes of visibility automatically display as what they are. So now we're going to go into the dynamic or visible work plane by 3 points. So you can see how whatever direction I move my mouse, you can see how it's locking that work plane by the 3 points. You can see the directions, you can see whenever I select a point what the actual work plane is going to look like before actually selecting it. So now we're going to talk about what's new in the layer manager. It is possible to add and remove groups by selecting items. You can see the icon here. When we select items, you can actually add layers and groups via the selection. You have a new option for filter by groups. So if you enable a certain group, only the layers that are enabled in that group will visibly show up on top. You can insert multiple empty layers in between by right-clicking a layer and saying insert more empty layers before. You can choose a quantity of layers, and this will put that amount of spacing within within the layer structure. You can do hide by entities. This is a new option within layers and layer groups. This option allows you to hide items by selection within the layer manager. And you have a back and forward preview selection, or previous selection. So you now can undo and redo what layers are enabled and disabled. This is a multiple instance, and you can go back and forward with these two new icons. You can apply a color to each layer or group. This color can be unique specifically to the layer and group. These are fully customizable and can be edited at any time. This adds a visual to be able to see what layers and what groups things are associated to. You can enable and disable the graphic color mode from this as well. So whatever color is in that layer group, that will display as a color for the solid or the faces, whatever is selected. Toggle this option on and off. So you can see, here's what the results look like. You can customize columns. So if you right-click on the layer manager, you have the ability to customize columns. So you can enable, disable what columns you specifically want on. So as an example, if you want to turn off the color mode, you can turn it off, and you can change the order of where everything is at. And a new option within the layer manager is called search and replace. Search and replace is a new function that allows you to search specific keywords and be able to see and find, and also replace these entities with these keywords. So let's go through some of these new features. You can see how if we select filter by groups, you can see all the layers that are actually selected. So if I turn this option on, you only see the layers that are associated to that group visible up in the layer manager. So as you can see, whatever layer groups are visible in that specific area, it only displays those items. If I right click, I can say insert empty or more empty layers, choosing the amount of layers I want. So you can see how it will put that spacing in there. If I enable my filter for unnamed layers, you can see that spacing in between all of the additional layers. If I go to assign colors, I'm going to assign colors specifically to a group. What this will do is whatever is a part of that group, you can see how it assigns those specific layers that color, just for easy visualization when it comes to searching for certain items. I can insert in a group or insert in a color via the individual layer as well, and I can reset the colors as well. So that resets the colors for everything, or reset the color for a single layer. So you can see how easily I can eliminate that option as well. If I go to customize columns, I could turn off that color column, and I can also display it at the same time and change the order of where it's actually at. I could do this for any one of those columns, making it easier to be able to customize and change certain things. So right now, if I go to search or replace, I can search for anything that has the name lower in it, and it'll highlight all layers that have that name lower in it. So with that search or replace, I'm going to go ahead and replace that lower option, and I'm going to replace it by adding in lower steel. And everything that has that name, it will apply that new change to it. Transform workplane mirror. There is a new option within the transform workplane to be able to mirror workplane. This allows you to mirror workplane via the XZ, YZ, and XY. When it comes to updating previews automatically, you have the ability to turn this option off and on. There is no longer the need to click the preview option. Frame alignment and dialog boxes. The fields that belong to different frames, collapsible or not, are aligned to each other. In this way, the field results are aligned, so you can see how there's a little bit more consistency when it comes to the dialog boxes. All of the fields will be aligned. And the escape key will stop a shade computation. So if you hold the escape key, it will prevent the shading from happening. This will allow you to speed things up if you accidentally bump the button. So let's talk about mirroring of workplanes real quick here. So as you can see, I've got my mirroring options here. If I go to enable this workplane, I want to mirror it to the other horn pin that you see, or the other slider that you see here. I can go to transform workplane. There is this new option for mirror here. So if I go ahead and select copy, I'm going to go ahead and select the mirror option, and I choose an application point for where I want that to mirror around. You can see how I have my XYZ areas, and I have additional dialog boxes here, so I can mirror this exactly on that other horn pin the exact way it displays on the one that we made the copy from. So you can see how here are some of the additional options for the mirroring. You can do some adjustments. So you want to rotate around YZ, XZ, XY. You can see how it's adjusting that workplane accordingly. Now we're going to get into some of the new enhancements with the pick and selection. With advanced filters and pre-selection, it is now possible to add a pre-select entity with other things specified. So you can see how you could do on same layer, same color, same description. So basically when you're doing selection, if something's on the same layer, it'll select everything on that same layer. With enhanced pick, you have the dimensions when it comes to doing some dimensioning for max and minimum presets. So when you select between 2 points, you can figure out what the maximum point is and the minimum point is between two areas. Enhanced incremental translation preview point. When you're using the translation command, it will show you and highlight a preview point of what you're actually going to select. This highlight point will change depending on where your cursor is selecting. Enhanced pick center face boundaries. In enhanced pick, there is a center face boundary that is calculated when you do a boundary of a face. It is no longer the area of the face. In this way, the position is not necessarily centered depending on the eventual inner trimmings. When you're doing enhanced pick, the insert XYZ offsets, it's now possible to do mixed rendering inside of here. So when you're doing your insert XYZ offsets, you put an MM or an IN depending on the opposite unit of what you're currently in. And in chain selection mode for wireframe elements, it's now possible to use an angular deviation. So this angular deviation allows you in this way to pick your chain of edges faster and independently work them off of the angular deviation. New to translation, you have the creation of a matrix for copies in the translation command. So within translation, you now have the matrix parameters. There's also inside the translation some quick key toggles. C for copy, M for move, and I for the incremental translation. This toggles between incremental translation and the point-to-point selection. So here's just a quick video kind of reviewing some of this stuff. So if we go to translation, you can see how we have copy, multiple copies. You also have matrix parameters. Inside of matrix parameters, you have the ability of putting in a specific distance, and you can choose which direction that distance is going to go, X, Y, Z, or both. You can choose how many instances you want for each item. and you can see how it's making a copy of each thing. You can choose the spacing of it or the total length as well. So if I put in a distance of 300 millimeters, you can see how that distance stretches across the entire area. Mouse configuration settings. You now can load predefined settings in other systems configurations. You have the ability to create a save configuration with existing ones. So you have the ability of using the control right mouse, drag, and pan, and setting those by default from other systems. Within file print, labeling options are now available and automatically input in the filing print. So the date, file name, and file path will now be available when you're doing your print. We'll talk about some of the 3D mouse configurations. So there is a new SDK that was introduced in 2024.3 to be able to integrate the 3D mouse. No longer will you have to establish a keyboard function for the buttons on your 3D mouse to be able to assign shortcuts. So there's more graphic functions as well that are allowed to be able to be used. So the fit, escape buttons on your 3D mouse will actually display as what they're supposed to be. And you have the ability of displaying the center rotation while you're doing rotation with your mouse cursor. So here's just a couple of images showing you some of the enhancements. So this is not through VISI, this is through the 3D Connection mouse drivers. You can see how if we are in 2024.3, you can see how it's showing up with the commands themselves. So here's just a quick video preview showing this. So if I search for my 3D Connection mouse here, this is the drivers themselves, and get into VISI, which is the active software here, we'll go into our buttons. You can see how if we scroll down, you will see that current version of VISI, and you'll see the active buttons that you can actually start to assign. So if I wanted, let's just say, a query command to be that button on the 3D Connection mouse, I can assign that button to that command. Under VISI again, if I go into, like, let's say, window, or anything here, you can see how we can start assigning other commands. So window, you could do your views, you could do whatever you want. And you can set these right through the drivers of the 3D Connection mouse. So no longer do you have to have a key linked to it, have the shortcut assigned to that specific key. These are independent from that. So you can set these shortcuts as whatever you want, and they are assigned the same way they would be assigned in VISI. So when you close out of the drivers, and you actually select these buttons on your 3D Connection mouse, they will establish what shortcuts are actually popping up. Like, let's say auto constrain was one of them, query was one of them, etc., etc. Now we're going to get into what's new with drafting and modeling. So start with drafting. Intersection between axis and surface. There's a new command in the points menu called intersection between axis and surface. This command allows you to create a point, an intersecting axis between a cylindrical face and a generic face. This is useful for doing a center axis on an inclined hole. So if there's a hole on a face that's not necessarily flat, you can still find the center of it. Trim elements at multiple selection. This command has been improved to allow multiple selection of elements to trim when you are in the command itself. It is now possible to trim off of a profile, face, body, plane, and so on. In some cases, single selection works as it does previously. So here's just a video showing both of these commands. So we have an intersection between hole and axis face. So when I go ahead and select one of these, as you can see at the standard commands, it is not selectable. But if I go to points and I use this new command here, intersection between axis and surface, if I select the face and I select this face, it will find the point and create a point in between those. This is great for non-planar faces. So as you can see, you can select these different types of faces. So if I select this line and this face, it still creates a point where those two are going to meet. So you got the draw axis line and so on here. So if I select this line and this face here too, it will still meet where those two intersections will actually be. From here, we got trim elements with multiple selection. So if I select trim elements, I can select multiple different elements, and I can trim these multiple elements to be able to create intersections. This is great for, like, for example, this example with a circle, where I have multiple elements to be able to select from. The side I select is the side I'm going to eliminate. And you can see how everything else that's selected, you can see how you can do reverse side, you can keep both sides as well. So the command will work as it did previously, but this multiple selection makes it easier to do trimming with your wireframe. So I select this profile, I say keep both sides or reverse side, it's going to show and display what you want to see. The command also works off of planes as well. So if I go ahead and select these pieces of wireframe, I can select this face and I can trim at that face as well. So this will work off of planes, this will work off of any kind of sheet body faces. So you can see keep both sides, keep selected side, reverse side. Basically it's like a split elements and it's trimming it at the same time. So in this example here, we're going to use that trim elements, but we're also going to trim along points. So you can see how we have different points here. When you select points, you can choose a direction at those points where you want to trim from. Again, with the multiple selection, we can say keep both sides, selected side, reverse side. From that, you can also adjust the distance of where that trim is actually going to come from via that point. It's going to get the direction from the point itself as well. From here, we have dynamic curves. In the wireframe drop-down, other curves, there's a brand new command, or a couple brand new commands, create dynamic curve and projected curve. These commands allow you to create a respective curve on a 3D shape and be able to adjust this curve dynamically per point that you're selecting. This provides better management of closed curves with tangencies. And with the blend between curves, or blend with curve command, you now can use this command with two selections. So no longer is it required to be able to pick your start and end constraints. You just pick between the two curves, and there is a slider bar that allows you to adjust that start and end point. You still have the functionality that you did previously with this command too. So here's the create dynamic curve options. So if I go into here, I'm going to go ahead and select these points. So when I'm selecting these points, I have the ability to, after confirming, adjust any of the slider bars to adjust how that curve is going to be represented. So I can drag and drop that curve. I can add additional points with this command as well, and adjust and edit these points with the sliders as well. So this allows me to have a lot more functionality within the commands. I can do close curves, repoint curves, I can force a tangency or do a normal tangency as well, and when I confirm it, it creates that clean curve right there. So this is creating a projected curve. So if I go to wireframe other curves, we have create projected curve as well. So basically on this face, if I select these points, or select the faces, and then I select the points, I could basically have that curve project and be forced to be projected on that face that was specified. So you can see you have that slider bar just like with the previous command. You can do your view direction, view orientations. You can imprint and apply these colors as well if it's going all the way through the part, but this automatically projects that curve onto those faces specified. So now we're going to get into the two-click selection with the blend with curve command. So I picked two curves, and no longer is it requiring the start and end constraints. You now have a slider bar to be able to adjust those start and end constraints. So it makes it faster to use the blend with curve command, especially if you're just picking between two lines and expecting for that blend to be able to tangentially create between the two lines. So you can see how fast this process is now. So we now have the ability to do a diameter input in the circular commands. This includes sketch, circle, cylinder, so on and so forth. So there's a toggle between these to be able to flip between radius and diameter. And with the wrap command, this has been improved to be able to do a wrap around a cylindrical shape as well as like a cone type of shape. So this allows you to achieve more results and cleaner results with the wrap command. Create profile drag window. There has been some improvements with the open and closed profiles. It is now possible to do multiple selection, and it is now possible to do a mixed selection between elements and faces to be able to create your profile. The classic method for propagating along the chain is still available when it comes to doing single element selection. The improvement options allow the dialog to work in multiple different cases. And with rectangle profile, the profile creation is now on the same icon as cuboid. So you have the ability to do an X center, Y center within this command. So the same options that were available in cuboid for being able to do this are now available in rectangle. So here's the create profile on multiple selection. So if I go to the Create Profile command, I could do a drag window, or I could do a selection. So if I select all of these, it instantly creates these as open profiles. Just by doing a simple drag window, these are all profiles now to be able to reference for machining, for whatever you need profiles for. And for the second area, these are closed. I could just do a drag window, and it creates two closed profiles on this shape. So you can see how it's going to create those two closed profiles. When we do this as well, you can still individually select these entities to be able to create these profiles, but now with the drag window, it makes it faster to be able to do your drag selection. Now we're going to go into what's new in modeling. So as mentioned before, finishing attributes. This is a new command within the modeling feature properties. This command is used to attach face attributes to any kind of faces associated, so for example, a finishing face and so on. This command is also used in the analysis mode, showing the color of the faces according to the finished value with color application. There is the possibility of applying a color during the analysis commands. Within Boolean operations, non-manifold edges, you have repair non-manifold edges with the blend command, which is now available. This command is off by default, and it will display a warning message when this situation comes up. In previous versions, the blend will be created without any default options. So let's go over the finishing attributes real quick in a video. So under modeling, we've got feature properties and finishing attributes. So when we're selecting faces, you have the ability to apply attributes to these types of faces. So you can add in any kind of upper or lower tolerances. You could do a surface finish value, plus or minus. You can set your face colors to this, and all this stuff is transferred over to CAM, transfer it over to your different settings to be able to display what the face type values are. So it's basically similar to what was previously in the software for assigning properties to a whole, but this is assigning properties to faces. So as you can see, you can assign certain colors to each one of these, and this will display in what was previously mentioned when we display face colors, where you can enable the finishing attributes as well as cylindrical attributes as well. So if you select an additional face, you can assign certain attributes to this. These attributes, again, are mentioned in the analysis dropdowns, query, etc. So as you can see, we are selecting query here. You can see the finishing attributes display within the dynamic query. Under Surface Analyzer, the same thing happens as well. So you can see how we show our finishing attributes at the very bottom of the Surface Analysis command. And the same thing with just a standard query picking the face. So now we're going to talk about managing a non-manifold edge. So as you can see, these edges, or these pieces of wireframe, are either overlapping or not touching at all. So if I went to Unite, I went into the properties, I go ahead and select this area, it will give me the message at the very bottom part of the screen to activate repair tolerance. When we activate that, you can see how it displays any kind of trouble zones or any kind of problem areas, and you can activate, and it prompts that message when it comes to adjusting certain values. So you have the option of repairing the non-manifold with a blend, and it will repair it with a blend as well. Continuing with Boolean operations, propagate by color. In multiple commands such as unite, subtract, cylinder, etc., you now have the ability to propagate a color of an entity on a subtracted body, or with a united body. This function also works with any kind of Boolean operations, create, subtract, unite, and other commands as well. With radial pattern, there is the ability to create multiple radial copies. The distance can be by length, and it can be by total length. So copies can be equally distributed by the length. You now can create an angular copy, which is useful for creating single features, and it requests for a rational pattern of copies at the same time. So here's the propagate by colors option. So in this case, you can see how the wireframe, you can see how it's going all the way through the part for each one of these, let's say, electrodes here. And if I go to Operation Subtract, I select my data, I select all of these entities, you can see how it displays all of those entities here. So some of these colors do display, some of them don't at this present time right now. So if I scroll down here, we can say preserve body color, which preserves all of the body colors when we're doing the subtract command. So this will retain colors inside the main block when it comes to the subtract command. This is also available in other commands such as, again, as mentioned, unite and cylinder. So right now if I do an undo, I can go to Operation Unite, and these body colors are different in each one of these areas. So right now you can see how that face color blue displays, but we can also preserve the body color in Unite. So this is nice for being able to preserve a body color so it doesn't just change it to the target body color. You can see how the wireframe lines stay the same, but it actually converts the body color into a face color for things that are being united. So now we'll talk about the radial pattern and what's new here. So within radial pattern, you can see how we have a multitude of different pattern type features. So if I go to the rotational pattern here, you can see how it shows up with that pattern where we can move, we can copy, we can do multiple copies. So if I say copy, it retains a copy. Multiple copies does multiple copies for however many copies that we want. You can do equally radial spacing as well. So equally radial spacing, you can see equally distributes the spacing between different items. Now we'll go to the one with an individual property here. We'll select the faces of it, we'll pick our point, and you can see how we have multiple copies already selected here from the previous selection. You can see how we have our different options in here. So if I did a full rotation, you can see how it does a full rotation. We do number of copies. It's going to equally distribute that full rotation off of one of those radial pockets. You can adjust the lengths very, very similarly and kind of get a similar result inside of this one instance command. We do equally spaced, and so on. So if I choose to, I could put in an angle. Adjust that angle, it's going to do the equally spacing. You can distribute the angle within the radial pattern command as well. So now we're going to get into what's new with extrude elements. When you're creating a solid using extrude elements, it is possible to project a profile on a non-planar face. Non-planar profiles can be extruded as a solid, which previously was not possible. We also have introduced a variable chamfer, very similar to the variable blend. It is now possible to add a variable chamfer, which works, like I said, similarly to the linear blend, where you can set application points for where you want that chamfer to progress from one size to a different size. Enable disable collision detection works with move a face and edit faces as well. So this function allows you to check the eventual collision of two bodies. So here's just a quick video showing some of these. So this is extruding a non-planar area. So when we're doing a non-planar area, you can still see how it extrudes this body as a solid. You can do certain distances, and you can still see, again, how this extrudes as a solid, even though it is a non-planar movement. You still have the ability to do extrude as a sheet body as well. And then here is our variable chamfer. We're going to pick this edge by a tangency, and you can see how you can display your first distance here and display a distance. So you can see how the chamfer type at the very top has now the variable chamfer. You can set certain application points for where you want that chamfer to change from a different size. So you can set this variable and change it to a different size and give yourself a different distance. So chamfer can progressively go from one size to a different size in a certain area. You can set constraining points as well. So now we are using the check collisions with edit faces and move a face. So if you go into here, you can select a face, and when you're going in to apply a distance, you have this check collision option, and it will highlight that collision while you're using edit faces. This option is available in move a face as well. Parallel 3D space direction. In Wireframe Parallel, you can now specify a direction for where the line goes. By default, the command works as it did in previous versions, but when you select a specific direction, for example Z, then the parallel will automatically go in the direction you specify. Project Elements Concatenate. There is a new option called Concatenate by Angular Tolerance in the Project Elements command. This option enables you to split the intersections at an extension. Adding this unique concatenated element allows you to specify angle deviations. Now we're going to talk about what's new within Bounding Box. In Bounding Box, it's now possible to set a Z orientation for the workplane creation. There are some options to rotate 90 degrees around X, Y, and Z, as well as reversing the Z around the X and Y icons. Very similar to Transform Workplane. It is now possible to rotate your axis around the workplane. And the angle information around the Z is available in Bounding Box when computing a minimum relative direction in Z. It is possible to rotate the calculated Bounding Box axis value to get integer values. Within Simplify Bodies, there has been some improvements with this, so it is possible to unmark split lines and relevant edges right from the Simplify Bodies command. The new option unmarks the split line and unmark relevant edges within the Simplify Bodies command. You can see the options here. So here's just a quick video showing some of the new things within Bounding Box. So basically I select the part, here's my Bounding Box. You can see under Create Workplane, you can see some of the new icons in here. We'll select this as our workplane. And then you can see the new options, rotate around X, Y, Z 90 degrees, and reverse Z around X and Y. So you can see hitting these options now applies that, very similar to how the Transform Workplane command would work. And now we're going to talk about the Bounding Box rotation. So you can see how we can select our different values. You can see how it squares it up flat to one of the sides. So if we do a minimum to relative direction, and I select a direction, there are new options to be able to rotate that Z axis. So as you can see, we start to apply a rotation, and that's going to change how this Bounding Box is going to be created. If I do a rotation angle, I could put in a specific angle, and you can see how it updates that relevant information here. So basically, when you are creating your Bounding Box, you are not having to square up a specific area, so you have some extra material left over. So if I go ahead and select everything, we can say align to the current workplane, or you can say rotate workplane axis, and you can actually type in your own custom angles. So if I say align to current workplane, you can select the checkbox here, and you can input that angle in. So this works with relative direction and align to current. Now we're going to talk about what's new with solid group feature instances. Under Boolean operations on feature bases for faces, it is now possible to apply a feature of a face and have the instance correct automatically. The new option is called Automatic Match Regions, and it is available in the Unite command and the Subtract command. Solid Groups Manager editing multiple groups. You now have the ability to select multiple solid groups at one time and edit the GRP file. Each group will open up as a separate VISI session, and when you close out of all of the groups, you will see the associated solid groups update in the file. Within Mates, it is now possible to add a solid group with a linked extension for a file. It is now possible to apply mates to external groups and other bodies. Solid Group Live Updates. When an external solid group is modified, a notification is sent to the VISI instance which a work file contains for the solid group to be loaded. If the solid group manager is open, there will be a notification at the bottom of the screen. And it is possible to close the solid groups manager and a message will appear to say, hey, this is out of date. Solid Group Manager sorting options. It is now possible to do an ascending and descending mode within Solid Groups. Solid Groups external files will always show up at the top of the list. When you're editing position, it is now possible to edit a linear, circular, and matrix pattern of groups. Solid Groups mirrored instances. Mirrored instances are placed in a subgroup separate from the original group. You will see a star icon for that group, and for any instances that contain any kind of rigid transformation, such as roto translation, these mirrored instances will be exported separately, as technically the geometry is different in a different position. And the process will be aligned to the instances concept of VISI. So the same concept of other systems for export will reflect inside the Solid Groups Manager. Now we're going to go into what's new with surfaces and meshes. So we'll start off with auto constrain. The auto constrain command has been improved with the edge selection, allowing you to use the trim elements at intersection within edges. In this case, edge selection works just like how the wireframe selection did, with extracting and trimming elements to create a surface. Modes like Inside Patch can work properly in this way, as they appear in the automatic solution list as a status for the trim option. Large Offset. There is a new option inside of Large Offset called Smooth Surface. This option allows you to adjust the number of points and the number of iterations within the large offset to achieve a better quality offset. So here's just a quick video. We're going to talk about the edge selection for trimming within auto constrain. So you see how we have this edge here at the bottom that extends past what our wireframe actually would reference. So we'll select the wireframe curve, and then we're going to pick all of our edges here. So if I were to go ahead and choose a solution here, you can see how it pops up with these options. If I select trim elements at intersection point, it actually will show up with more options and build the surface properly. So I'll talk about large offset. So you can see here is what our large offset looks like in comparison. So this is what it looks like when we don't have that smooth option turned on. You can see how we can have the original model comparison to what CATIA's results are. And now we're going to go over the large offset with the smooth option turned on. So you can see what the results look like before and after. So you can see the number, or you can see how we're going to apply an offset. You can see the number of X points, number of Y points. Obviously the higher amount, the cleaner your model is going to be. But we also have the ability of doing a smooth surface down here. So we'll check this box, and it's going to use the number of points, number of iterations from the smooth surface. So it's achieving a similar result to what we had in the CATIA software. You can also do a cut plane with a peripheral edge, and basically it's going to create a very similar offset. So it's going to create the offset and could create a solid block as well as a sheet body as well for this. So basically what this does is this is going to allow you to create a surface very similarly, and it's going to improve the large offset type of command. So as you can see, we just created a solid block out of that with large offset. So we'll talk about fillet surface. There is a new column called typology, which in the fillet surface creates an immediate edge. Within Unite, retain relevant edges, it is now possible to retain relevant edges on laminar borders for a surface within the Boolean operation Unite. This makes it possible to keep relevant edges and outer edges during the Unite process, joining one surface or solid together. Within split plane, there has been some improvements with the wireframe elements. There's an option, reverse direction, to act on the direction of the created split line, basically out to in or in to out. There is another new option, reverse draft orientation, to reverse the direction of the eventual draft angle that's going to be created. So in this video, we're going to show the fillet surface here. So we'll select our edges. We're going to select the first side. We'll select the second side here. And as you can see, it creates a surface. Now there's no edges on the surface necessarily, and that's where this new option comes into play. Column typology. So basically what this does is it creates the edges. So you can see how minimum does not, column does. And now we're going to talk about uniting relevant edges. So you can see how we have these two separate surfaces here. One has edges marked as relevant, one does not. And if we select the properties box when we're using the unite command, you can actually make it so it no longer, with simplify turned on, even if they're separate surfaces, detaches those relevant edges. Now from here, we're going to talk about the split plane. We have a open profile here, and you can see how if we do by offset, by scale, you can see how if I did a positive offset as a certain value, you can see how we can do our surface extensions. Now from here, we can reverse the orientation by simply just selecting a box, and it flips that direction around. So you can choose one side or the other side. You can also apply a unique draft angle to each area, and you can see how it applies that draft angle. You can reverse the draft angle as you choose to as well, which will flip the direction from one side to the other side. We're going to talk about what's new with mesh. There's a brand new command called typological mesh. In the new version, PK mesh is generated in parasolid, generally called typological. This mesh type is treated like a solid when they are closed, or sheet body when they're open. They represent a slightly different graphics, like the classic mesh, to distinguish them. Using this type of mesh object, it is now possible to achieve some results. There is the ability to be able to convert these solids to topological meshes, as well as convert classic STL files to topological meshes and vice versa. It is possible to list these inside the Assembly Manager tree, and you can calculate the weight of a closed topological mesh and represent the part in Plotview using different shading modes with textures. So going off of what we were talking about before, you also can apply Feature Manager holes to the solid topological mesh. So you can also use Boolean operations inside of this, as think of this as a hybrid solid. So here's just a quick video showcasing a topological mesh. So basically, I'm going to load in a STL file or a JT open file. So you go in here, you load it in. You can see how it shows up as a topological mesh. So this is a fully functional closed mesh here that you can see. So you can see the new command inside the mesh drop down for topological mesh, and this shows you the number of unconnected faces. So under mesh, we can use the similar mesh cleanup commands as well to be able to clean this up. Connect it all together, kind of like a unite command would do. So then we'll go into topological mesh, we'll go ahead and select everything and basically join it together as one mesh. You've got some options here, so surface, close to solid, etc., which basically functions similarly to how a solid and surface would work with most VISI types of commands. Under System Settings Graphics, we can display the transparency for a topological mesh as well. None, or the minimum, will basically show no lines, and then maximum will show the lines as solid, kind of like how a mesh would look in the standard view. You can see how we can do dynamic sections with the topological mesh, and they display kind of as a solid here, as you can see, if it is a closed area. You can see these inside of Assembly Manager. It does display the data as if it were a solid. You can assign properties to this mesh and add this information into your bill of material. So if we do a query, a weight, or bounding box, you'll be able to apply and see what the weight is for that topological mesh, as well as see that it is actually that type of mesh. So when we have it as a solid block, you can see how you can get a weight off of that solid block. When we select assign material, it assigns the material and as well as assign weight to the Assembly Manager. As you can see, You can see the material and the weight applied. So now we're going to insert some features into this topological mesh. As a solid, you can see how it actually puts in a hole. These areas can be machined, and this topological mesh would represent as a solid for machining. So we can apply simple modeling commands such as edit faces within topological mesh as well. So you can see how we could drag and drop this area and change the length of the mesh itself. We can apply blends, chamfers to the mesh, and so on as well, so you can see how it applies that blend. So for our next example, we're going to select this surface here. So you can see how this is a sheet topological mesh here, and you can use similar functions to it. So if we select this as a face, you can see how it shows up at the face type as well. We can use change attributes and change the color of it as if it were a sheet body or a solid. You can see what type of element it actually selects as well. In our dynamic query, you'll see the same type of thing. Now we're going to go to what's new with the analysis commands. We're going to start with mates. So mate wireframe relations. It is now possible to create wireframe relations within mate. There is a new option called show constraint labels, which allows you to display the labels for wireframe mates. This new option is called create constraints on elements to easily quickly assign relevant constraints to a chain of wireframe. It is now possible to apply the coincident constraint to the ends of each wireframe area. Point selection has been added and combined within this. Mate face relations. It is now possible to apply a constraint between faces and not just the entire bodies. Moving the face from one body to another will not move the entire body, just the faces specifically. The transformation between one body face constraint to another body, the second body can be transformed, moving the entire body, but the body with the faces linked, for example, will move to the represented distance of the constraint. So here's a quick video showing the mates for wireframe. So you can see how we have our display area down at the bottom part of the screen. We can create constraints for all the wireframe. So if we select everything here, you can see all of our wireframe constraints. So you can see how it automatically adds all the rigid sets, which are the pieces of wireframe, and the coincidents, perpendiculars, tangencies, and so on. So you can say show constraint label and display the label for each area, as you can see. So we've got mate face constraints. So you can see how we have a rigid set, we have a distance set for some of these constraints. So if I set a distance constraint face to face, this will affect any command such as like a move a face. So when it moves a face, one face will be moved with the other face here. So as you can see, when we select this face, you can see how it adds and adjusts all of those faces. You can see how the bodies change for everything else as well. So let's go to this example here. We're going to apply the face as a rigid set. So as you can see, we have one face here, we have the other face here as well. And if I apply a distance between these two faces here, it adjusts those faces. So if I do another edit faces here, of course, it's going to edit and adjust very similarly to the other one. So as you can see, it is adjusting the faces properly from there. But let's just say, if I go in here and enable this distance, so it's forcing that distance from that face to the other face. If I were to do an edit faces and apply the same thing to all of these, it will adjust the edited face, but the distance of the locks will actually remain the same. So going back to edit faces, we'll select this face here. You can see how all the locks do apply. We can apply another movement or another constraint to that center pocket to apply the same thing too. It is now possible to set equations for mates. So these equations could be, for example, D1 is a distance between two faces or apart. D2 could be the distance between another group of faces. So the equation could be D2 equals D1 times 3. Every time you use this distance, it would reflect the calculation of the equations. So as you can see, you can apply equations now inside of your mate constraints. Mate selection that belongs to a group. You now can select an element that is part of a solid group and apply a movement within motion study. Within mate radius constraints, there are two new mate constraints that you can apply. You have radius and equal radius. It is now possible to define a circle, arc, or hole fillet, which you can add a constraint for equal radius and so on. You now have the possibility of creating a radius constraint to these entities and link them using an equation as well. So here's a quick video showing the equations. We'll begin with that first. So you can see how we have a distance d1. You can see how these are labeled conveniently as what they actually are. So in an equation, you can use these values. So you can see how we have equidistances between these two distances. You can see the equation here, d2 equals d1 divided by 3, d3 equals d2 divided by 3. So you can see how we have these different equations. You can input any kind of equations in here. You can add your own equations to this as well. When we apply a modeling command such as edit faces, it will factor in these equations when we do our mate constraints. So if I put in a distance, you'll see that it's going to make the adjustments in relevance to the equations. So you can see how it not only does it adjust that side, but it also adjusts the other sides as well. So you can see how it's calculating that equation as it's going through its entire process of adjusting your values. So now we're going to go into our new radial constraints. So we got equal radiuses here. We'll select that first. And you can see how it automatically changes the sizes of all the holes in relevance to the initial face that we select. So we can then apply these radius constraints here, so equal radius. And basically, this is going to apply that constraint to all of these. So you can change the blends pretty quickly. So you've got blends, fillets, radiuses, and so on. So if I make a change to one, it makes a change to them all based on that mate constraint. So you can see how if we adjust one radius, it adjusts them all. Then we have the general radius constraint here. So when I select a radius, so we'll select this radius and this radius here. That's going to add those radiuses. You can see how we have an R1, R2, which could be used for equations later as well. So if we select equation, we'll do R1 equals R2 divided by 2. So basically what that does is going to apply that constraint to all of the faces that are in relevance to that based on when we had the equal radius selected. So you can see how we can highlight all of our constraints. We can disable these constraints. So if we disable them, any changes that we make that constraint is not necessarily relevant to, it will be disabled and it won't actually apply those. So continuing with mates, we have constraint displays. The mate constraint labels can be enabled and disabled through the display from the graphics label area. So you can see how it displays the graphics here. And now we're going to get into query distance. Measuring curved faces. You now can put a minimum and maximum distance between flats on a curved face. With query angle, you can display delta angles. It's now possible to display delta angles to calculate the angle between two query angle areas. These angles can be calculated from a plane passing between the two entities, and it's now possible to calculate the angle of the projection on 3 different coordinates, xz, yz, and xy. And now we'll talk about solid interference. For the minimum distance and hole distance, it no longer is required for you to have the mold or progress license to be able to use these functions inside of the analysis dropdown. The calculated times for generating the solid interference have been improved. The calculated data is stored in the current session, so it can be retrieved for next use in the command and in the next session. So the application for solid interference applies contact faces, which now gives you the possibility to do a direct color of the body or face to be applied to the contact body, as an alternative to the unique color as before. There is a new option, show only curves on new edges, to create curves on only the new detected contact boundaries. Existing edges are skipped. There's a new option for mark edges as relevant that cannot be simplified. Duplicate curves are automatically deleted, And there's a new option for ignore threads in interference, which ignores any threads for a screw during the solid interference command. Cavities and wire points are skipped by the selection as well, so the entities are not adding false collisions into the analysis. And it's now possible to zoom and hide other areas within the solid interference command. So here's just a quick video. So we're going to select the results on apply. So we select all of our entities here within solid interference. So you can see how it shows up with our interferences here. So we have different settings. So we can show interference zones. We could turn off interference zones. When we imprint a contact face, we can do a colored contact face, and you can change the unique color for that. So you can say use contact face color. So instead of actually applying a unique color, it would actually apply the color of the current solid itself or the solid that it's actually interfering with. And then the same thing for contact intersection faces as well. So you can say show only curves on the new edges. So this would display only curves on the new edges. So anything that's got an outer boundary would no longer display, only showing the curves of any intersections or any contact faces. So if I were to apply this, you can see how it's going to apply the unique color on the opposite body. So for example, we do the attributes of visibility, we select this red face, and anything that is a contact face of anything that's making contact will change to the relevant color of that opposite face. The same thing if we flip our visibility, you can see the color of that red body apply on the other bodies where it's making contact or even where it's colliding. You can see how we mark those edges as relevant as well. And under interference curves, when we select our entities, you can see where you have only contact faces. So you can say show only curves of the new edges. So it no longer selects anything that is existing. So you can keep the curves and apply the curves, and it applies those curves to it. And for this area, this is really nice when it comes to molds and dies. You can ignore the tapped threads. So right now, as you can see, it doesn't highlight anything here because we have ignore thread interference. If I uncheck this box, you can see how it looks like as before, and it's basically eliminating any kind of false collisions that we may have. Now we're going to get into motion study. Within query distance, it's now possible to simultaneously use motion study with query distance. Selecting locked bodies. You now can select locked bodies to apply motion study simulation to. A warning message will appear when you have these locked body entities in here, letting you know that, hey, these are locked. Explode Manager selection. It is now possible to be able to pick more than one entity in the Explode Manager tree. This is in the case of multiple selection of parts when you're trying to remove multiple different entities from a step. In the case of selecting multiple sections of a node, the delete option will be available. And within dynamic section, you now have the ability of creating a section by a face. So when you're selecting a face, you can create a section specifically for that face. Here's just a quick video representation of that. So, as you can see, we're cutting a section. We can select an application point where we want that section to be made. And then from the application point we choose, we can create a section where you now have the ability of creating a section by the face. So basically we can select what we want face-wise, and it will create a section only specifically for the faces we select. Within weight, you now have the ability of being able to set more units for relevant outputs for volume and weight. So as you can see, kilograms, grams, pounds, ounces, and then also millimeters cubed, centimeters cubed, meters cubed, liters, inch, feet, yards, and fluid ounces. There's a new tab in here for moment of inertia. The weight command displays in a much cleaner look and a clearer aspect. You now have the ability to apply, cancel. You have the ability to restore defaults and save defaults. So whatever values you have set, you can save those as an overall default. This option is useful for being able to create and show specific graphic labels. There's another option to be able to show and assign parts without assigning a material in two specific color areas. And value rounding for decimal places can now be specified through system options, much like how query works. You now have the ability to swap between units for center of gravity as well. And here's just a quick video showing the improvements of the weight command. So as you can see, we have all these pins, we have a main pin, and we have the rod here. So if I go to the weight command, go and select everything, you can see how I could display total weight. So you can do pounds, grams, ounces as mentioned before. And when I switch, it does update to that relevant information. You also have the ability of changing volume. What's the volume measuring out as? Millimeters, meters, inches, centimeters, feet, yards, etc. So same thing for center of gravity. You can switch back and forth between center of gravity here. And you can say create labels, and it shows a label of what materials you could have previously assigned using the assign materials, assign weight. And it shows any materials that have assigned materials, and then it also can show any materials that are not currently assigned. You can say use materials, you can display total volume, total weight, etc. And we also have moment of inertia. This shows the moment of inertia for center mass as well as origins by coordinate systems. You can change the mode of unit that it's going to measure off of, and this is going to be able to allow you to create your different information. Now we're going to go into what's new with electrodes. We'll start with electrode tip creation. So the electrode command is now electrode tip creation. It's now possible to select solid groups within the electrode tip creation. You now can select a solid group workpiece in the stock command and the electrode manager. You can create electrode tips on faces with locked solids and locked solid groups. And it is now possible to select a locked solid as a piece to check against for collisions. There is now the ability to assign color of the stock, and you can add a unique positive negative length and width within your electrode creation. So here's just a quick video representing this. So you can see how we have the electrode command here. You can select your specific electrode you're trying to generate off of. And then from here, we could do by solid box. This enables the bounding box options, very similar to the standard bounding box command, where you can apply a unique length, unique width. You can apply translations, you can apply the face color for where it's burning, and so on. So if I go ahead and activate these, you can see how there's new slider arrows to be able to generate a unique positive, negative length and width. If you didn't have these options selected, it would just equally distribute the positive, negative length and width on all sides. So right now, we're going to use the replace face with surface command here. If I went to modeling replace face with surface, we're going to go ahead and select the flat surface here. If we didn't have a flat surface conveniently, we could use, let's say, our offset. We offset it to whatever distance that we want. This is great for being able to create a flat face or kind of mimic what will become the stock. Within Electrode Project, the Electrode Project is automatically populated in the Electrode Manager when the first electrode from stock has been created and associated to a workpiece. Process Direction. You now can define the electrode working direction in the stock command. This is also possible through the Electrode Manager. You can now dynamically modify with a slider the initial start point and the electrode movements. This makes it easier to be able to do incline movements and so on. You can do a complete simulation and define the path and check for collisions within this. So let's just go over that command. So process direction. So we go into either stock, or we can use this from the Electrode Manager like before. And you can see how there is a new button, Set Point Process Direction. So this makes it very easy to be able to show and simulate where this is actually going. So right now we're doing a vertical. We can set an inclined where we basically just pick a path where we want it to go, and you can see how the electrode's now going to follow that path. You can change the initial, you can change where the actual application points are going to be, and you can check for collisions right from this command. Much easier to use than what it was in the previous versions. So that process direction is also available inside of the Electrode Manager as well. So let's just go over that real quick here. So if I right click, you can select the process direction command and basically reset that process direction from here. It's basically the same command, but is now included with the stock module as well. Electrode mirroring. Mirrored electrodes will now belong on a different sum from the original electrode. It is now possible to customize the extension to use in the name for mirrored electrodes. This makes a reference on the same side of the original electrode. You can correct and manage the holders if preset when the electrode is mirrored. The stock dialog no longer appears to confirm the mirrored electrode, and adds a position by drag does not require a dialog for confirmation. So here's just a video just showcasing the mirrored electrodes. So in our electrode settings general, you have the ability of customizing the name of a mirrored electrode. So we're doing _M here. So if you go into Electrode Manager, we can select this electrode and we can select mirror. Basically from here we choose to move or copy. You select the application point where you're going to mirror this around. You can see a preview of what it looks like. You can select copy, and basically it's going to imprint that electrode onto your area. You can see how that custom name shows up as an electrode. It's actually a part of a separate group now. Enable disable erosion area. The advanced erosion data has been calculated within the erosion area and will work the following ways. If the option is on, the system will do as it previously did. The erosions are calculated for creation, dragging, editing of the electrode. In this case, the default will fail with the advanced calculation when trying to do more attempts. If the option is off, the erosion data will not calculate in creation, dragging, editing, mirror, and so on. It will be possible to calculate later when the data is now specific with a new button inside of stock definition. In this way, it is easier to manage electrodes with complex geometry and will be faster, avoiding the automatic computation of erosion every time when you make a change. Within stock definition, the interface definition, formerly stock, has been improved. There's a new tabbed dialog to easily manage and navigate through the stock definitions command. Options are collapsible based on the groups and the radial buttons. You can see here's what the dialog looks like now. Options in the command and messages and labels have been improved to better describe the functions. The message area has been added at the bottom of the command, and it will provide warning messages during the stock command process. And it is now possible to select relevant elements directly from the stock dialog before the action is required within the command. For example, Z or manual process for the electrode origin will be prompted. There is the possibility of selecting bodies for collisions in the collision tab. In this case, it would be skipped in the section and is not necessary to add or remove other parts of the workpiece. The selection button has been added in the dialog in this piece, which is necessary to select sometimes in graphics. So let's go over the stock interface here. You can see here's your stock definition. We go ahead and pick the electrode, we go ahead and pick what it's actually going to be burning into. And you can see here's what the new dialog looks like. It works from left to right, where you can see the general notes, you can see marks, you can see origins, you can see the attributes, as well as collision all the way on the right. So the attributes basically replaces what was the EPX tab in previous versions, but you can see how we can actually define these in different order. You can see how when we pick a manual work plane, it no longer is required when you hit the checkbox to confirm. It will automatically prompt that work plane when you're actually selecting manual. You can see how we have the collision. You can select the bodies that are colliding. You can select the workpiece. So it's kind of working similarly to the solid interference. You've got your calculate erosion data that automatically populates as well. And then under general, this is where you change your general stock size, your electrode names, and so on. Stock size from list. When the size from a list is used, the system will purposely create the size that best fits the electrode. It is now possible to change that size afterwards from a list. Electrode origin. Electrode origin definition has been added to the stock definitions. This allows you to use the electrode name, and it is possible to insert in a username for the electrode. Milling origin. In the origin tab, it is now possible to add a secondary origin, an origin for burn position and an origin for milling position. And here's just a video showing some of these areas here. So stock size from list for the when we're creating an electrode, you can see how it automatically picks from a list. We can say use list sizes, and you can actually select your own sizes. These sizes can be customized. You can add your own sizes in as needed. So for example, 1 inch by 1 inch by 1 inch block, 2 inch by 2 inch by 2 inch block, and so on. From here, we're going to repeat this same example. We'll select this block. You can see how it does the resizing, automatically finding the electrode size that is required from that list. So it's easy to kind of templatize your stock definition. You can see how this one automatically goes to whatever the next size up is and includes the proper heights and so on. You can still manually adjust your width, depth, and diameters and so on as well, but this is just a new feature. Now we'll talk about milling origin. You've got your reference origin positions. You can set it to stock bottom face, and then you also have a milling origin, which you can then set as a different application point. So if you're burning and milling at different positions, it's now pretty easy for you to set up your different positions for both and create a work plane for both at the same time. So I go ahead and confirm it. You will see that it does create 2 work planes, and under the origin area you'll see the original work plane and the milling work plane. Marks. Marks are now in their own tab in the stock definition window. It is now possible to create marks on the heel, the stock, or both within this mode. And it's also possible to set a limit on the chamfered mark, kind of similar to the create edit chamfer command. Holder minimum stock. When the height of the stock is less than the holder clamping clearance, there will be a warning message letting you know this. There is an option to have the height automatically recalculate in regards to calculate for the holder and the stock and versus the collision piece. So the collision check warning highlights the colliding faces and allows you to see the information. So this is just showing you the chamfer limiting stock. So if we go into here, we're going to go into actually creating your marks. So as you can see, here's the heel size. We're going to go into marks. And for this, we can apply a mark on the stock, on the heel, or both. You can set a certain direction like you previously were able to, and set the certain height wherever you want to go. When adjusting for the height, you can see how the chamfer automatically updates in relevance to that. And if I go back to marks, I'll do marks on heel, and you can see how it applies to the heel, or I'll do marks on both. And when I do marks on both, I can set a chamfering limiting height and limit the height of the chamfer itself. So as you can see, on the stock, it will limit the height of the chamfer. So we're going to talk about the stock holder placements and some of the new features when you're inserting in a holder on an existing stock. If there isn't enough clearance for the holder itself on the stock and it collides with your body, it will show up with an automatic warning message. You will see that in this video here. So if I go to holders from library and I select a holder here, this one clearly collides with the part, which you can see. But let's just say I place it, you will see a message, and it will automatically adjust the height for you if you choose to have that setting set. So as you can see, it automatically adjusts the height of the stock to fit that holder in there and avoid collisions with your main body. If I were to create a heel in here, you can see how that holder automatically updates and automatically raises up as well, and so on. Electrode sizing icons. Sizing icons will be available in the stock definition command. The same UI of other commands as property trees like feature manager, right click, etc. will have the measurement icons here. So as you can see, if you right click, you will see the measurement icons inside of stock. Origin by reference. It is now possible to mark a face for the holder reference for the Z value height, which the origin must be created from for holder reference in the origin list. The option is available in the Electrode Manager, where you can right click on the root when it is possible to present a holder as a GRP GRS file. In this way, it is possible to mark faces of a loaded holder and use those faces or do the same action of a custom library. When the holder has a marked face, the holder reference will appear in the origin list. And it is also possible to sort your property tree by ascending, descending, and the creation order. Use electrode size. When a minimum stock is aligned to the current work plane, XY directions are retained to avoid a 90-degree angle. The size of the computed stock is exactly the size of the tip of the electrode. Width and depth are not grayed out, so a user can round the calculated value as needed. The option is working in the edit mode as well. And within Note in 3D, it is now possible to see origins of an electrode to be created inside the Note 3D. Reports for relevant information of the electrode are the same, and it is possible to display these values when you are using a 3D note. So here's just some definitions for the stock sizing information. So you can see how we have our electrode stock. You can say use electrode size, and it's going to automatically adjust to the electrode size. So if you define your stock within the electrode tip creation, you can use that electrode size and round it up if you need to. Now we'll talk about the Note 3D. You can pick your origin, and it will display all of the information, including the electrode origin, the absolute origin. You can see all the coordinates just by simply selecting that origin. You can see all the information about the electrode itself when you do a 3D note. Now we're going to go into what's new in Plotview and Dimensions. So within Plotview, text on axis. Draw axis text is now an option, so you can display the XYZ letters for the absolute and the relative origins. This is available in a single view and multi-view creation. Sorting of groups. The groups of page names can be sorted by ascending and descending, and for all modes by name or custom. And there's a new option to be able to search through a specific page. So you can search for keywords under the Manage Page tab and search for pages that have a common keyword. So here's just a video going over some of these. So you'll be able to see these two options: draw origin, draw origin for absolute, relative, and then there's a display the text. So if we go into here, we'll go ahead and place this view. And what this will do is it will create our work planes for both the absolute and relative origins in the detail view. So now we'll go over the search function within Plotview. So you see I have a long list of pages. Under the Manage page, we have search pages. You can search for a keyword in here, and when you search by that specific keyword, it will highlight all the pages that have that keyword in it. So you can see exactly what pages have what names in it. So under the Search Page tab, we can also select pages and display only those pages specifically. Anything that has that page name in it. So it's kind of like a filter, so you can hide certain things as well. Break associative dimensions. Most dimensions placed on a view can be retained or can be created with breaks on the view. Breaks do not remove the positioning of the dimension. Dimensions cannot be updated for any reason once they are broken. There's a warning prompt before you use this type of command as well. The dimensions now across the area create a break and are updated, showing the real value of the zigzag mark. Break along a defined direction. It's now possible to select a direction for your break instead of just doing horizontal or vertical. This is great for being able to access an angled pin. Whole dimension tolerance string display. When a whole string is defined, then the dimension will show this by default only the string, not the numerical value. Before the entire tolerance string was shown, the information is redundant. This can be defined within Feature Manager and automatically defined when the dimension is created. If a whole does only have numerical values, that will be what it's going to display as before. It is always possible, of course, to enable the tolerance string and show the numerical values together with the string as for the wanted results. Single element feature recognition. Single element dimensions on a section hole by default will show the diameter symbol, or the tabbed symbol for UNC automatically. This result is obtained by selecting two section lines for the hole cosmetics, or selecting the top segment of the hole. So here's just a quick video showing the diameter feature recognition. So I have a bunch of details in here, I have a bunch of holes. When I show a dimension, I'm going to go ahead and select it, and it automatically picks up the diameter symbol. So as you can see, when we're selecting elements, we're selecting holes, it automatically picks up as what they are. So here's a cut section for this. We'll pick in between here. You can see how it automatically puts a diameter in there, recognizing that this is actually a hole feature with the cut section. So you can see how we do the same thing on this side, and you can see how the sidewall still displays as normal. So here's a area with a tapped type of feature. So we pick our tap string, and it automatically picks up what the tap string is, such as M, such as UNC, etc. And if we pick the inside hole, it picks up as a diameter as well. You can toggle through the different options like you were able to before, but you can see how it automatically displays as whatever the feature is. Fractional dimensions. Values of features that were created with fractional representation will now display with fractional representation when it comes to a dimension callout. For example, 7/8 by 14 with a depth of 1 3/4. Electrode view reset status. It is now possible to reset the status from the electrode view area inside of Plotview. The pull down will work very similarly to the electrode manager as shown here, so we can delete related pages within the electrode view tab inside of Plotview. Under annotation text, it is now possible to create margins within the annotation text command. So you have left, center, right justifications, and it reflects that when you are creating a text using the annotation text command. Details and outbreak sections. It is now possible to do a detail on an outbreak section. The detail must be completed or completely included in the outbreak section view, but it will be able to allow you to create a detail off of an outbreak section. So detail and outbreak sections are considered as separate entities when editing as well. Add layers in views by groups. It is now possible to transform a layer view that has been created with multiple different groups inside. You got this in add, remove, layers, and groups. Within 3D boring chart, you can specify a separator for the 3D boring chart. This new symbol, like Assembly Manager, allows you to create a separator when you're doing a CSV export. Workplane text orientation. The plane of the text that is created is updated on the fly. So when you're creating a view XY, XZ, YZ, this makes it possible to create your text on side walls and makes it easy. So it automatically updates the orientation when you are creating text. Update views with multiple solids. You now have the possibility to repair a link of bodies when it comes to creating your view of parts containing multiple solids. It will prompt this update box when you're doing this. The body with broken links is highlighted in the view and updated, or it gives you the option to update it properly. And save part as with associated Plotview pages. When you're doing a save part as, if you have associated Plotview pages, it is possible to export those out when you're doing a save part as. Part list creation updates. It is now possible to update a view with a lost solid due to the deletion or due to any kind of settings, and the eventual ID change will now reflect. Before, this was skipped and the fixed link was not possible. Section creation. It is now possible to create a section on a detailed view. The size of the section will display as the same size as what the detailed view scale is, 2:1, 5:1. Automatic mask application points. You now have more options to be able to select from for your application point when you're placing a mask. For example, we have top right, center, left, right, or bottom left, top left, so on and so forth. Just like you would when it comes to placing other things. Under alignment constraints, you have the ability to do a default on and off. It is now possible to create page management and create an aligned view without alignment constraints. So this is great for multi-view. So if this is unchecked, you can translate, you can move, you can do whatever you need to do with a view, and it's not going to automatically be aligned to another view when this option is turned off. Note 3D. In the Note 3D, it is possible to create it as a label. This option converts the 3D text to standard to a query-based type of label. It is possible to create all labels on a solid at the same time using the Note 3D. You now can edit the Note 3D in the Edit Dimensions area. This allows you to customize and change the color of your 3D note when it comes to creation. So here's just a quick video representation showing the 3D note options. So if I go into 3D note and I pick a face here, you can see this is what it looked like before, but we also have the ability of creating the note as a label. It's very similar to query. So you can see how I can place this view in here. When it comes to adding all the notes into it, we can go into here and select multiple faces. We can select the entire body and it displays a note for everything here. So right now this is showing up with all the different faces. You can see under attributes we can even change the color of these displays as well. But you can see how when we pick a face or pick some area on the part, it displays all of the information. This includes the finishing attributes we mentioned earlier. So when I go to Edit Dimensions, I can edit all the notes at the same time here. And when we select one, it's going to edit all of the notes. So again, as I mentioned with the attributes, this is where we can start configuring a color and customizing certain things. So it changed the background color of that 3D note. Annotation cross. There's a new command called single element within the cross command. So this allows you to individualize the different segments that the cross command creates. So for example, with this off, the cross shows up as one entity. With this on, it shows up with the cross as separate entities for each item. And within dowel pins for mark visualization, it is now possible to be able to enable and disable the cross representation here. You can see the setting, and this is also available in the General tab inside of Plotview. And now we're going to talk about standard elements and feature manager. Within standard elements, you'll now get a warning message when a cavity cannot be rebuilt. In this case, it is now deleted and healed with the subtracted cavity. A warning message is shown to help you understand the reasoning why, so you can manually close the relative cavity. There's also a warning message when it comes to element insertion. The system will automatically show you a warning message and advise you regarding any kind of element insertion when there is an issue. The revision of the warning message has been improved to correctly handle the different application points. In tool design, a warning message will not be shown, but feature manager will display the invalid area. Sprue bushings. Sprue bushings for the SB2 and SB3 have been improved to set options such as user database data or head inside a block as true to the added options, which allows you to choose if the element should be linked to the top or the bottom of the face. Ejector pin locks. Lock position normally calculates with a formula. With this enhancement that's been added, it is now possible to set a lock value based off of the rules database table for locks. It is now possible to define a value different to 0 in specific lock databases. So here's just an example showing the sprue bushings. So we pick a top and a bottom plate, and you can see how you have some adjustments. Use a database value, or use the head inside a block. This allows for a little bit easier transitions between two blocks. So here's a different sprue bushing in two other sets, so you can see how the heights change. You got use database value, use head inside a block, and so on. So it automatically adjusts the height of the sprue when it comes to making these types of adjustments. So pick the top and bottom again. You can see how it shows up with an error message about the invalid parameter, as mentioned before. So if the height is not deep enough, it will pop up that parameter. You can use the database value and you can set the height of that sprue inside the block. And I will talk about the lock positions for ejector pins. So we'll pick our ejector plate, our core plate, and we'll create a pen. You can adjust the diameters to whatever it needs to be. And then we can then apply our lock. So from this, you will see that these values are no longer a formula-based calculation. You can change lock positions manually. You can adjust them through a rules table. So here's our rules table for that. You got database lock position as a new field. Right now it's defaulted to 0, but you can change that value to whatever you want. So if we start changing some of these values, save this in the database, go back in, insert in another ejector pin, and apply a lock to it, you will see that value we just updated in the Microsoft Access database. This is something that is possible to update inside the standard element configuration files as well when it comes to adjusting the lock rules. So as you can see right now, when we set that value, that lock position now defaults to whatever we set it to. There have been several catalogs and databases that have been updated. Dimensions have been updated and reviewed in reference to customer requests, and listed below are the catalogs that have been updated. More specifically for the US base, we got Progressive Components, DME, PCS, Self-Lube that have been updated in the 2024.3 release. Now we're going to talk about what's new in Feature Manager. Edit multi-simple features. In cases where we have multiple holes without attributes, there were limitations that did not allow the user to reference these faces. These limitations have now been removed. This option will save the user time in a one-step process instead of a two-step process to define these values. Topological mesh. As mentioned before, it is now possible to insert in a Feature Manager hole as well as standard elements through a topological mesh. These features can be edited through the Edit Multi-Simple features as well. Repicking faces after. It is no longer required to reference a selected face to create holes even after they were picked in the past. Adding features. There's a new option allowing the user to define a new feature within Feature Manager. Starting from an existing feature, you now have the ability to copy a different feature that can be defined in CAM attributes such as colors and descriptions for a new hole. This makes it very useful for creating custom features, which saves a lot of time in comparison with manual solutions. Once applied, the feature will now be in the features configuration files as displayed, so you can customize colors, and they'll also display as what you define them in Surface Analyzer and CAM Navigator. So here's a button, here's the icons, and here's a quick video showing some of these new features. So we got repick faces. So you can see how we're trying to insert in these holes within a slotted area. So we pick this face, you pick the certain height, you pick an application point where you want the hole to be defined. It will create that feature. And going further, it is no longer required to continuously pick that face to be able to create those types of features. You can see how we can do the equidistance, and it no longer is requiring us to pick the face to be able to repeat this process over and over and over again to build these features. So now we're going to talk about adding a feature. So inside of Feature Manager, you can see that there is a new button to add a feature. You can see how here's our drop downs for drilling. You can see how we have different definitions for different things here. And then we have this add button. So basically it's going to take the properties of what is existent, and then we can put in our own parameters, put in our own colors. This could be useful in the future when it comes to defining CAM attributes, using Compass inside of VISI and so on, because you could define a feature right from here. As you can see, we're going to name this drill 31, and we're going to change this to a custom type of drill feature. This will apply inside the feature config file to be able to edit colors, which we could do from this drop down here as well, but this allows you to define that feature as what you want to define it as. We'll set that color to a goldish color here, and that feature is now going to be applied upon an application restart. So if I reopen up VISI, you will see the drop down for that type of feature. So under Modeling, Feature Manager now, if we look in the Drilling dropdown, you will see Drill Custom. Drill Custom is the new feature that we just created, and it will have different attributes listed for that specific hole. So you'll see that the color that we've selected will apply, and this allows you to add more features inside of the feature manager. So as you can see, let's check this out inside of Surface Analyzer. It will pop up with how our feature is defined. Under Feature Properties, we'll load that Properties file, and you can see how that feature is now applied in here too. And the same thing is true when we run Feature Recognition. So within Feature Recognition, you will see that that name, that column for that feature is defined the same way. Now we're going to go into what's new with mold. We're going to start with part definition. There's a new option called Create Unlinked Shrunk Part that has been added to the part definition. This allows you to remove the linking between the original solid and the calculated solid with shrink. This will make it possible to run new calculations within part definition on the shrunk solid. Within Body to Mold, it is now possible to delete a body with mold attributes. Under Browse Mold Part, there's an option called Remove Part. Basically, it removes the linking of the part from Body to Mold. Within Tool Design, there have been two new layers added for ejector standard elements and mold tool design settings. So you can create new standard element linking for the ejector plate as a stop button or as a screw, and they'll show up in a different layer. Within cooling, you now can maintain the cooling elements associated to a channel by using the split and adapt to a new plate. Crossing channeling definition on cooling management has been enhanced as well to make it possible to reference channels, which saves time during the circuit definition. Here's a quick video just kind of reviewing some of that. So we'll talk about the cooling standard components here. You can see how we have different components set up. If we go into tool design, we make a modification to that tool, you will see that these components will automatically split and adapt. So right now they currently haven't, but as you can see, if we go into the conformal, or if we go into cooling here, we select split and adapt, it automatically re-references the new sizing of the plates. This saves some time because you don't have to adjust any kind of lengths or anything like that. You just re-solidify afterwards. So even if I use a standard modeling command like edit faces as well, you can achieve the same results in it. So if I go back to cooling, I go back in and re-split and adapt, these components will fully update again. You have to resubtract, but this does save some time when it comes to modifying, as the split and adapt is more so automatic. Here's an example of something that wasn't defined within tool design as well, just so you can see. So you can see how the components don't necessarily split and adapt, but when I re-solidify them, it does. And now we're going to talk about warpage compensation. It is now possible to exploit mesh computed with the warpage from the compensated comparing to the original model. This is achieved through the target-driven deformation, or TDD for short, available in the morphing dropdown. Simply select an STL file for deformation in the analysis dropdown to generate the compensated mesh. The latter would be to be used within the warpage analysis. So here's just a quick video showing this. So you got warpage compensation. You go and select the mesh that was created through flow or through TDD. So you can select the deform mesh, you can select the reference mesh. So you got both meshes in here. So this is a deform mesh. And what it's going to do is it's going to calculate the warpage between the two. So this makes it easier to be able to redefine your meshes, comparing the TDD mesh to your flow mesh to your original model. Here's just another example of that. Select the deform mesh, select the reference mesh, and it will create a compensation between the two. Basically allowing you to reform the shape between the two models and compare how much warpage you could see between the two models. Now we're going to get into what's new with flow. Model preparation. The MSC core meshing library used within mesh parts has been integrated with the latest version improvements for both time and quality for modeling processes. Under filling, There is a new option called Analysis Documentation, which now creates an HTML format. This format can be viewed in all kinds of different web browsers, such as Edge, Chrome, Firefox, etc. Under Materials, there's been a long tradition of bringing updates to materials. The completed updates are to carry out all the active information provided by customers and provided by some of the suppliers. And for thermal, there's been an additional option to the thermal analysis measurements. This option is called Sections on Insert. Now we're going to go into what's new in progress. Within part unfolding, ribs and bosses on linear bends. Some improvements have been made to the following. You have the ability to do better trimming on features in cases of holes being in different shapes. Adding an option to use deformation algorithms just when necessary. You have the ability to set an angle to 0 degrees. It is also possible to set a flat area for faster and more powerful results. Angles different from 0 degrees, default is flat, but users can adjust that. Applying thickness. There is a new option called Apply Thickness. This option allows you to calculate the thickness of an unfolded part. This is useful for complex parts where systems can do a lot of time to think about the thickness. Here's just a video showing the ribs and bosses first. So we'll go and select this linear bend, and if I put in a new angle here, you can see how that rib and boss adjust in regards to that. So we put in a new angle here. I'll add another step. You can see how that rib and boss also applies to those, and you can see how that rib and boss becomes flat as we go throughout our unfolding process. Same thing is true for these areas here. Here's another example where we have a little bit more of a complex rib and boss that affects two linear areas. So if I go and select one of them, you can see how it flattens that rib and boss for the entire thing as we're going through our unfolding process. Just keep this process going as we go throughout the rest of this, forming our die stations. All the way out until we get a semi-flat part. And then you can see how we can start doing our linear unfolds for the rest of it. Now we're going to talk about apply thickness. So when we're doing a part flange unfold, you can select your part that we're unfolding. There's an option called apply thickness, or if you uncheck this option, it will create this as a flat sheet. This does save some time when it comes to regenerating your part unfolding. So if I turn off the apply thickness, you can see how it actually just unfolds it as a sheet body as well. Part flange unfolding. Within the mesh improvements, there have been some speed improvements with the D&E method for being able to generate these types of meshes in a quicker time frame. Under morphing, there is an option that has now been under morphing. The morphing option has been improved to work in circumstances with not so ideal geometry. Flange features. Features that are now defined will now retain the part flange unfolding. So as you can see, here's a quick video showing these not so ideal solutions. So you can see how within the morphing area, you can see how we have some sliver surfaces, some bad faces in here. What we're going to show that is within part flange unfolding that it's still going to unfold even with these not so ideal situations. So we're going to select these faces to preserve. And even if not so ideal geometry, it will still unfold those areas. And when we select maintain, it's maintaining the other areas as well. So when I select face constraints, I can then set another die station, and even with the not so ideal geometry, it will still unfold these areas. Now we're going to talk about flange on features. So you can see how there's a feature in here. We're going to define it as such. And when we do our part flange unfolding, this will also at the same time retain that feature during the unfold process. So we're doing this at a 45 initially. You can see how that feature still shows up when we do the unfold on the back side. So it's just like the preserving of faces, it's preserving the feature so it doesn't flatten the feature during the flange unfold. Springback solver. Springback solver by scanning. This command allows you to calculate the compensation of a part even if the selected meshes are not correctly linked, or the data provided is not from a scanned operation mesh or cloud. The user is only able to work on nominal meshes and scanning clouds. The nominal mesh is optional now. If the point cloud comes directly from a scan, it will be necessary to play with the parameters in the preview to get the best results. If pre-filtered, the function can take care of this itself. As with other methods, an offline function has been made available to create linking of a point cloud. Here's a quick video showcasing this. So we have Springback by scanning. What this does is it allows you to select your entity, it selects your nominal or your point set, which can be skipped, and it selects the springback mesh and point set. So we can compute the springback from that, and you can change your different nominal or normal values, you can change your different search distances, and so on. So as you can see, it creates the different mesh groups. So from here, we're going to do springback from scanning as well. We've got a point cloud and we've got our part. So entity to change, that's our part. And then we got nominal mesh or point set, which we can skip. And we can create our springback point sets to be able to create some results from it. So as you can see our point set, you can see the normal model, and you can see how the entity changes. In this last example here, we're going to select the linked parts, and we can relink these parts, creating a point set, creating a segment linked part. And then when we go ahead and confirm it, you can see how it's linking those points in relevance to a mesh that wasn't necessarily defined from VISI. From here, we're going to go over a brand new command inside of the progress dropdown. This is called incremental simulation for multi-stage simulation. In an increment of a progressive die simulation, the molding process is divided into several stages and operations. Each is represented in a different step of the production process. During each operation, the accumulated effects of the previous step are considered and evaluated when it comes to doing your simulation for material of the progressive transfer. The methodology allows the detailed process for evaluation of the material during behaviors of the production die process. This allows you to identify problems such as deforming, cracks, springback, and enables the engineer to optimize the production process and improve the quality of the final product. Incremental progressive die simulation are widely used in the manufacturing industry to predict material behavior and optimize parameters, which reduces the cost and improves efficiency to ensure compliance with quality requirements. Here's a quick video showing what the incremental simulation does. So I've scanned a part, went into the analyze faces, and I've scanned the part, turning these sides into flanges. From here, I can go into our part definitions, set this as our primary face for the part, and we can create our blank off of that. So basically we're creating our different stations to be able to unfold this. So we're creating the different stations. These different stations will be then simulated with the incremental simulation. So as you can see, we're starting that process of creating all of our die simulations. We've got 4 stations all together here. So now we're in tool definition, and we've defined these tools for our die side, our punch side. And then we're going to use the incremental simulation using those feature areas to be able to create our simulation for this. So we are in what is called incremental simulation here. We're selecting our faces, we're selecting our binary surfaces, we're selecting the distance of how far that face is actually going to go from the die side, punch side, and what's the distance of how it's going to actually strike the part. So your punch stroke, you're adjusting the heights, you're adjusting your Z levels, and so on to match up. This will affect how the simulation is actually going to go. You can choose a rounded step distance, you can use the sliders to create your distance, and we're basically just creating all of our different stations and simulating all of our different stations. The nice thing about this is it references previous stations, so it knows what it did in previous simulations. So as you can see, we're setting our step-by-steps, and then we're going to run the simulation of this. So you can see how, just like with blank, where it's doing one simulation, this is doing multiple simulations at one time. It's calculating each simulation of each die station and preventing any kind of issues when it comes to doing your scan processes. We can control how many steps each station is going to have, and you can see how the simulation is running on multiple different areas. So this is under the display results area, and you can see how it's doing your die simulation from this. You can choose your different steps and simulate from those different steps. Now we're going to talk about what's new in reverse. Within reverse, we have load point cloud options. From file open, you now can import point cloud information. If the normal information is included, there will be no additional prompts. Otherwise, like before, it will ask for those normal computations. Within surface generation, you can now define a direction on a replace face. The reverse function replace face with plane or radius, given the possibility to define a perpendicular or parallel direction to reference for a face or a direction. Draw surface. This is a new command that allows you to draw a boundary on a mesh to be able to create a surface. Users can choose to input straight lines, curves, to create a surface on a mesh. And within one-click surface, there's a mesh subdivision. The mesh subdivision has been added to the one-click mesh to allow you to create wireframe surfaces or both from a mesh. And thanks for watching.